Hey y'all, we're looking at lesson 5.2. This is another lesson that we are getting into before getting to the main part of this unit, which is exponential functions. This is writing terms in a sequence using recursive processes. So first of all, what is a sequence? Well, it's a set of numbers, right? And we're going to get into that, into the specifics of those sequences in just a second. Okay, but that's what a sequence is. And we're going to talk about what a recursive process looks like as well. So our learning target for today, I can write terms in a sequence using recursive processes. So first of all, there are two types of sequences. There are arithmetic sequences and there are geometric sequences. And we're going to talk about both of those today. So first step though is to identify, is it arithmetic or geometric? Notice that it says I can determine if a function is arithmetic or geometric. We're kind of talking about linear functions in a way, and then a different type of function. But we're just talking about it in a different way using a recursive process. And again, we're going to look at what that means. So that's the first step. The second step is to identify the first term of the sequence. We always need to come back to that first term. And then you're going to need to identify the change of the sequence. What is happening from one number to the next, from the first number to the second number, to the third, to the fourth, to the fifth, and so on. And then after that, apply the change to determine additional terms in the sequence. Say it only gives you 4 terms. Well, it wants you to find the next 3 terms. You have to apply what that change was in order to follow the pattern. Essentially, sequences are patterns. Let's take a look at arithmetic sequences first. An arithmetic sequence is a sequence of terms that have a common difference between them. In other words, you can add or subtract the first number from the second number to determine the pattern or sequence. Now, I love using that word pattern. That's really all you're identifying here, guys. So if we look at example number 1, we're trying to find the pattern. And again, we can use the first term, and we can either add or subtract it from the next one to determine the pattern. So example number 1, we have the first number 3. That's our first number, right? It's the first one listed. That means 5 is our second term. 7 is the third, and 9 is the fourth, right? But we care about the first one. That was, remember, that step, okay? We know that's arithmetic because it's under the arithmetic category, and arithmetic sequences, or the difference, it always has a common difference, which means you're either adding or subtracting some number. It's always going to be by the same number. So if we take 3, we can subtract 3 from our second number 5 to figure out that common difference. In other words, how do we get from 3 to 5? We add 2. How do we get from 5 to 7? We add 2. How do we get from 7 to 9? We add 2. In other words, the common difference, which we use the letter D to denotate, is 2. Don't really need to put positive 2. It's known as positive right there. Right? That's the common difference because that's what I'm adding my first number by to get to the second number. And then that's what I add the second number by to get to the third number. And what I add the third number to get the fourth number. So can I use this common difference to find the next 3 numbers? Yeah, I just follow the pattern. So I just add 2 to 9 and I get 11. And then I add 2 to 11 to get 13. Then I add 2 to 13 to get 15. Right? I'm still just adding 2 every single time. Let's look at example number 2. Example number 2 is also going to be an arithmetic. My first term is 16, and then it goes to 11, 6, and then 1. Well, how do I get from 16 to 11? That's always how I think about this. Okay, remember, I can add or subtract. Now, I know 16 and then 11, and then 6 and then 1. It's getting smaller. So my common difference this time is going to be a negative number. It's subtracting. Okay, so I'm going to subtract 16 from 11. And if I want to even write it over here, I can. And whatever number I get is going to be my common difference. But you can also think about it as, how do I get from 16 to 11? I go down by 5. I'm subtracting by 5. And to get from 11 to 6, I'm subtracting by 5. To get from 6 to 1, I'm subtracting by 5. That means my common difference is negative 5. And I could keep going with this pattern. 1 minus 5 is negative 4. Negative 4 minus 5 is negative 9. And negative 9 minus 5 is negative 14. Holding true to that pattern of just subtracting by 5 each time. Now, I can also use my calculator for this, right? I don't have to use my head to think or write down like I did right there. But I can, right? But no, you can use your calculator to help you out. Oops. Okay, so those are arithmetic sequences. Now let's learn a little bit about geometric sequences. Geometric sequences are a sequence of terms that have a common ratio between them. In other words, you can divide by the first number in order to determine the pattern or sequence. Again, when it says divide by the first number, you're dividing the first number by the first number to the second number. So you're dividing the second number by that first number in order to find the ratio. So let's look at example number 1, where we have the pattern 4, 8, 16, 32. It's a common ratio, it's a geometric sequence. We're talking about multiplication and division here. And we can find that out by finding that first number, 4, and dividing our second number, 8, by that first number. So I'm going to look to divide 8 by 4. Now, this common ratio is actually going to work with any of the two numbers. Just divide the second one by the one right before it. Right? So I could also divide 16 by 8, 32 by 16. And it's going to get me the same ratio. Those are all going to end up being the same common ratio value. This one, dividing 8 by 4, gives me a common ratio of 2. I can also think about this in terms of a pattern. This one's not arithmetic because it's not increasing by 4 each time, right? From 4 to 8, that was an increase of 4. But then it goes 8 to 16, and that's not plus 4. That's how we know it's not arithmetic. That's a great way to rule out arithmetic. If you try to add something, it's not going to be the same number you're adding by each time. So, okay, what if we move to multiplication? 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So this time it's multiplication, just times 2, times 2. So in order to continue that pattern, we need to multiply by 2 each time. So let's go ahead and do that. 32 times 2 is 64. 64 times 2 is 128. And 128 times 2 is 256. Looking at example number 2, we have the numbers 15, 3, 3/5, and 3/25. Remember, we can take that first number, 15, and divide the second number by it. So I'm looking at dividing 3 by 15. Now, if I could simplify this number, I would. It kind of looks like I can simplify it, so let's simplify it. 3/15 is the same as 1/5, which means 1/5 is my common ratio. It means I'm multiplying by 1/5, which means I'm actually going to be getting smaller, which you can see in this pattern, 15, 3, 3/5, 3/25 is getting smaller. So in order to find the next three terms, I multiply by 1/5. Now, I'm definitely going to use my calculator on this one because I don't want to multiply by 1/5. And you can definitely use your calculator too. You can also think of multiplying by 1/5 as dividing by 5. 15 divided by 5 is 3. 3 divided by 5 is 3/5. 3/5 divided by 5 is 3 divided by 20, or 3/25. And so on and so forth. But we will always talk about the common ratio in terms of multiplication. So what you were multiplying by to get the second number, right? And when I told you to find it in that geometric sequence, I used the word divide. right? But it's really, what are we multiplying the first number by to get the second number? What are we multiplying the second number by to get the third number? So always think about things in terms of multiplication. That is going to be the key for geometric sequences. So arithmetic, adding and subtracting. Geometric, multiplication. Or dividing, right? And we can use division to help us. That's kind of how I even set it up. But you're always thinking in terms of multiplication when it comes down to identifying that common ratio. You never want to say dividing by 5. You want to say multiplying by 1/5. Right? Don't write that one. Even though technically it's going to get you the same answer. Now let's look at what the heck is recursive processes, right? We learned about arithmetic sequences and geometric sequences. What is arithmetic, or what is an arithmetic recursive formula? What's a geometric recursive formula? Let's take a look. So you'll see them written in two different ways. One in terms of a sub n, which is typical to sequences, and then sometimes written in terms of a function. That's where you see that second one, that f of n. So let's look at the top one first. For arithmetic recursive formulas, you see the equation a sub n equals a sub n minus 1 plus d. Remember, we talked about what d is. It's the common difference. So make a note of that. D is the common difference. And you just learned how to find that on the last page. And then it also makes a note to say that a sub 1 is the first term. So if a sub 1 is the first term, then a sub n is the term given whatever term number it is. So that little n is referring to the term number. Right? Is it the first term, second term, third term, fourth term? And then the a sub n is the number as a whole. If you think back to our first example here, 3, 5, 7, 9. 3 was our first term. So the n would be 1. But the a sub n, or a sub 1, is equal to 3. And we could actually label that, and you'll see us do that. Now, a sub n minus 1 means you take the term before the term you want to find. And that's how we found it, right? We took the term before and added the common difference. That's always how you find it, right? We took the term before, we took 3 and added the common difference. We took the next term, 5, and added the common difference. We took the one before, or we got 7, then we took that one to find the next one. Right? That's all that formula is explaining right there. In terms of the function, the f of n, it's written like that. F of n equals f in sub 1, or not, sorry, it's not sub, just f parentheses n minus 1 plus d, where f of 1 is the first term. This is exactly the same formula. It's telling you to take the term before the one you want and add the common difference to it. It's just written in a different way, and it's important to understand both of these methods because you could see it written either way. Let's look at two examples here. Example 1, a sequence is defined by f of 1 is 30, and f of n equals f of n minus 1 minus 4 for each whole number n where n is greater than 1. What are the first 4 terms in the sequence? So I can write 1, 2, 3, 4. That's the numbers I need to get. I know 30 is the first one because it told me. That's what f of 1 equaling 30 means. Okay? Now, to find my f of n, and in this case my f of 2, I need to get f of n minus 1. Well, what is the n in this case is 2. So what is my f of 2 minus 1 and then minus 4? What is this right here? It's actually f of 1. And what is f of 1? 30. It's my first term. So all this is saying is take the term before and subtract 4. That's my common difference. So realizing that that's what it's asking is going to be important for you. This part right here is just saying take the term before the one you want. So 30 minus 4 is 26, so that's going to be my next term. Then that's going to be the term that you want to use. Subtract 4. subtract 4. Now you have the first 4 terms. Okay, if you wanted that more detailed breakdown, I'll have it on the end of the video that you can kind of pause and look at how we broke down and used this formula here to kind of break down each of those. I'll have that up for you so you can see if you want to add them, but there's not a whole bunch of room there. Looking at example number 2, a sequence is generated using a sub 1 equals -1, and then a sub n equals a sub n minus 1 plus 9. N's a whole number greater than 1. What are the first 4 terms in the sequence? Well, it tells us a sub n, or a sub 1, is -1, which means -1 is our first term. What are the next 4, or the next 3? Well, again, this is going to get us our term if we take the term before and add 9. So the first term, right, to get a sub 2, the second term, we need to take the term before 2, which was the first term, and add 9 to it. Okay, so that first term was -1. Add 9, you get 8. To get a sub 3, take the term before it, and minus 1, which is 2, and add 9. So now we take a sub 2, which was 8, and add 9 to it, 17. To get the fourth term, we just do the same thing. So we take the term before it, a sub 3, and add 9 to it. So 17 plus 9 is 26. Okay, that gives you a little bit more of a picture. It's the same idea no matter what the formula is looking like, if it uses kind of more function notation or if it uses that a sub n, more common to sequence notation. Okay, identifying that plus or minus at the end is showing the common difference is important. Finishing up with geometric recursive formulas, it's similar in that it uses both a sub n and f of n, and we're talking about multiplication, right? Not adding and subtracting. So that multiplication comes from the letter R here and here, and we're just multiplying it times the term before. Multiply times the term before. So in both cases, that a sub n minus 1 and the f parentheses n minus 1 are referring to the term before the one you want. Always the term prior to the one you're looking to find. And again, as I told you, we're always going to deal in terms of multiplication with geometric. Now, you can use the division to help you think about it, but it's always in talking about in terms of multiplication. So looking at example number 3 here, a sequence is defined by f of 1 equals 2, and it gives us the f of n equals 4 f of n minus 1. There's my common ratio. There's my R. What are the first 4 terms in the sequence? Well, the first term it tells us is 2. And then I'll get my next ones by just multiplying by that common ratio. 2 times 4, 8. 8 times 4, 32. 32 times 4, 128. All we did was multiply by that common ratio, and I'm using my rule. Something that is important to notice is maybe it doesn't give you the first term, but it gives you the rule. If it gives you the common ratio or the common difference, you can still find the pattern and work backwards and forwards to find any number of terms you need, as long as you're given at least one term to start with, because you already know that common ratio or the common difference, right? In example number 4, a sequence is generated by using a sub 1 equals -7, so there's my first term, and a sub n equals 1/3 a n minus, or sub n minus 1. So 1/3 is my common ratio. What are the first 4 terms? Well, the first one is -7, and then what are my next 3? Multiply by 1/3. So to find a sub 2, I need to take a sub 1, which is -7, and multiply by 1/3. I would continue this pattern, take the a sub 2, whatever it is, and multiply by 1/3 to get my next terms. So there we are, completing the pattern, just multiplying by that 1/3 each time. This is arithmetic and geometric formulas, how to use them. Okay, I know this video was super long, but I wanted to make sure you kind of understood it. You have a short practice now in Google Classroom. Let your teacher know if you have any questions.